This video will include solutions to section 6.2 homework problems. Section 6.2 is cylindrical shells. I'll begin with problem number 6. Problem 6 says, use the method of shells to find the volume generated by rotating a region bounded by the given curves about the y-axis. So our first curve is y equals 3 plus 2x minus x squared, and x plus y equals 3. And remember, we want to go about the y-axis. This is a parabola that opens down, right? We can factor that if we want. That's going to be equal to minus x squared minus 2x minus 3, or minus, and then we get x minus 3 times x plus 1. So our x-intercepts are 3 and 1. So if now we're going to revolve this around the y-axis. So if we draw this, we have an x-intercept of positive 3, an x-intercept of negative 1, and it opens down. Then we have a line y equals, if we solve this is y equals minus x plus 3. So it's a slope of negative 1, or y-intercept of 3. So when x is 3, right, when x is 3, y is 0. So that goes through here. And then the y-intercept of this, right, we can put a 0 in here and a 0 in here. The y-intercept of this is 3, so that's this point here. So our line goes like this. So this is the region that we're working with here. We want to revolve that around the y-axis, about the y-axis. So we have a similar shape over here. And they want us to use cylindrical shells, right? That's what they asked us to use, shells. So we make our hypothetical slice. If we slice this way, it would be washers. And we would have to go function to function here. But if we do shells, then we're going vertically. Make our cylinder. So remember, our method for shells is that the volume is going to equal the integral of 2 pi times the radius times the height. In this case, it's going to be dx, because our slice is perpendicular to the x-axis. Now, when we look at this, we have to find the radius and we have to find the height. Remember, the way we do this is we label this point x, y. This point here is also x, because that's a vertical line. Those are the same x coordinates, but this is a different y. So we'll call this y sub 2, we'll call this y sub 1. Our radius here, this is our axis of revolution. So our radius goes from here to here. That's going to be r. And so that's just using our Cartesian plane. That's just x. So r is going to equal x. Our height, however, is going to be y sub 1, the height minus y sub 2. Now, our function h is supposed to be a function of x, right? Because we're integrating with respect to x. So we have y sub 1 minus y sub 2. This y value minus this y value gives us our height. But those are not functions of x. So we need to simplify those. We need to know who this y value is. Well, that y value is the parabola. So that's 3 plus 2x minus x squared minus this y value. Well, that y value is, don't forget your parentheses, minus x plus 3. So here we get, if we collect like terms, that's a +3. That negative makes that a -3. So those are gone. Here we have a -x². Here we have a 2x minus a minus. That's going to be +3x. So our height is going to be -x² plus 3x. So now we'll plug everything in here. We'll put our 2 pi out in front. We're going to integrate between 0, right? Because that's where we start. We start at 0. We end at 3. So we're going to integrate from 0 to 3. And now we have our radius, which is x, times our height, which is -x² plus 3x dx. We now just multiply that out. So that's going to be 2 pi. The integral from 0 to 3, we're going to have -x³ plus 3x² dx, or 2 pi. We integrate this, that's going to give us -x⁴ over 4. We integrate this, that's going to be plus 3x³ over 3. And we're going to evaluate that between 0 and 3. These 3's cancel. And now we just plug in our 3, plug in our 0, and do our arithmetic to get our volume. Okay, I'll let you do the arithmetic so that I can avoid embarrassing myself by doing it wrong. So that's number 6. Let's take a look at number 12. 12 is x plus y equals 3. And that's the same line that we just worked with, coincidentally. And then we have x equals 4 minus the quantity of y minus 1 squared. Right? So we may want to do a little review here. This, if we're going to write this in our standard form from pre-calc, this would be minus the quantity y minus 1 squared plus 4. And our standard formula in pre-calc was x equals, and then we had something like a times y minus h plus k, something like this, right? Where we can find our vertex. This is going to be our friend, a sideways opening parabola, right? So if we draw this, what is it going to give us? Well, if we put 1 in here, x is 1. Right? If we put in if we put in y is 1, then we're going to get 1 minus 1 squared, that's 0 squared. We're going to get x equals 4. So when y is 1, x is 4. That sits here. Then this parabola opens left because we have a negative sign, right? It's a sideways opening parabola because x is to the first power, y is to the second power. This is our vertex, and now it opens this way. So we need to find the y-intercepts. Now, to find the y-intercepts, we set x equal to 0, right? That's what we do. Now remember, this is 4 units here. Well, if we set x equal to 0, what do we get? We get something like 0 equals minus y plus 1 squared plus 4, or y plus 1 squared equals 4. What do we square to make 4? Right, that's what this says. And the answer is going to be 2 or -2. If I put a 1 here for y, 1 plus 1 is 2, 2 squared is 4. So one of my intercepts is y equals 1. Well, that doesn't seem right, does it? Because we said we put 1 in here, we get 1 minus 1 is 0, so we get x is 4. Here, when we put 1 in here, oh, I made this a plus over here in this part, didn't I? There's our mistake. There we go. It's y minus 1. So I need this to be a 2, so I have to put in 3, right? 3 minus 1 makes 2. 2 squared is 4. So one of our intercepts is here at 3. And then the other one is going to be -1 minus 1 is -2 squared. That's going to be 4. So our other intercept is going to be here. So we have a parabola that opens this way. All right. Then we have the line. We know about this line. This is our line y equals minus x plus 3. So it has a y-intercept here at 3. It has an x-intercept at 3, which is right here. And a slope of -1. So our region is this piece right here. This is the region that they want us to rotate. Now, if we read the instructions for problem 12 says rotate this about the x-axis, okay, the x-axis. So we want to rotate around here. Now we have to take a look and see which way we want to slice this. We want shells. If we were to slice it this direction vertically and then rotate it, remember our reflection is right here, right? Here's our reflection. It's right here like this. There's our reflection. So if we were to draw this vertically and spin it, that would not make a cylinder, that would make a washer. So we're going to want to go horizontally. Plus, if we went vertically, over here we would be going from function to function. We don't want that. So we're going to get a cylinder that looks like this. Right? And now our job is the same as always. Now, these slices are pointing at the y-axis. So our volume here is going to be the integral. It's going to be 2 pi. It's going to be the radius. It's going to be the height. And it's going to be dy. So we're going to want our radius in terms of y. And we're going to want our height in terms of y. So we have to take a careful look. Now we're going to label this point, right? Like we always have. This is the point x, y. We're going to label the other point here. This is also x, y. But when we take a look at this, we realize those are different x's, right? Those are different x's. So we'll call this one x of 1, put a comma there. We'll call this one x of 2. Those are the same y values. So what's our radius, right? What's our radius? Well, our radius is this distance right here, right? This is our radius. And we know what that is. That goes from the x-axis up to this point. So our radius is going to be y. So we don't have to do any work there. It's already in terms of y. That's wonderful. But our height is going to be the right-hand x minus the left-hand x. So that's going to be x of 1 minus x of 2. But that's not in terms of y, is it? So we have to figure out who is x of 1. X of 1 is the parabola. The parabola is x equals 4 minus y minus 1 squared. So that's going to be x of 1. It's going to be 4 minus the quantity y minus 1 squared. Minus x of 2. X of 2, we have to solve this for x. We didn't solve it for x to draw the graph. We solved it for y. So if we solve it for x, we get x equals -y plus 3, right? That's what we get. So this is going to be minus, don't forget the quantity now, -y plus 3. Now, the easiest way to do this is just to FOIL everything out and collect like terms. So we're going to have 4 minus, this is going to be y squared minus 2y plus 1 when I FOIL that. Minus minus y is going to be plus y minus 3. So that's going to be negative y squared from here. Here I'm going to have minus minus 2y. So that's going to be plus 2y plus a y. That's plus 3y. Here I'm going to have negative 1. Here I have negative 3. That's negative 4. Here I have 4. So those all cancel. So this is our height. So we can plug that in now into our integral. Plug it in our integral. So we're going to get volume equals, we'll put our 2 pi out in front. On the y-axis, we're starting here, right? This is the bottom of our region. The top is at 3, so we're going to integrate from 0 to 3. Our height is going to be, our radius is going to be y. Our height is going to be minus y squared plus 3y dy, or we're going to have 2 pi, the integral from 0 to 3. We're going to have minus y cubed plus 3y squared dy. And of course, that'll get us 2 pi. Integral here is going to be minus y to the 4th over 4 plus 3y cubed over 3. And of course, those 3's cancel. And we're going to evaluate between 0 and 3. And I'll let you do the arithmetic. All right, so there's problem 12. All right, taking a look at the homework assignment here. Let's go ahead and take a look at problem 16. All right, problem 16. So problem 16 is y equals x squared. Y equals 2 minus x squared. So those are both parabolas. And then we want to go about the line x equals 1. So we're not going about an axis here. We're going about a line. So we're going to probably have to use multiple brackets, our 3 bracket method to find the height and the radius. But we won't know until we do the sketch. So we're going to go about x equals 1. So we'll make it bigger over here. So when we spin it around x equals 1, we can get our whole picture in here. First, we have y equals x squared, right? That's our parabola that opens up. It goes like this. And then we have 2 minus x squared, right? That parabola is up here at 2 and it opens down. So it goes like this. So our region that we're going to work with is going to be this shape right here. Right? And remember, our top parabola is this one, right? This is the parabola that's on top. This is the parabola on the bottom. They intersect at 1, 1. If I put 1 here, I get 1 squared is 1. If I put 1 here, I get 1 squared is 1. 2 minus 1 is 1. So this is the point 1, 1. Now, our axis of rotation is the line x equals 1. That's what it said in the book. We want to use shells. If we were to go horizontally like this and spin this, it would not make a shell. It would be thin. It would make a washer. And we would be going from this function to itself. We don't want to do that. So we're going to go here, draw our typical rectangle, right? Here's our typical rectangle. I guess I didn't draw the reflection over here, did I? So the reflection of this goes like this, and it goes like this, right? Here's our reflection. And so our matching typical rectangle over here would be here. And then we would have a cylinder that looks like this. Remember, this is the line x equals 1. Now, we have the same steps that we have in the past. We want to find the radius and we want to find the height, because the volume is going to be the integral. We're going to get 2 pi, we get the radius, we get the height. These point at the x-axis, right? So this is going to be dx. So I want to find my radius in terms of x, and I want to find my height in terms of x. So I have to find my radius. Now remember, this is our original shape, this is our reflection. So our radius is right here. This is our radius. It goes from the axis of rotation, remember we're rotating around here, to our slice. That's our radius. Now we have the same question that we always ask. What are the coordinates of this point? Well, that's xy. What are the coordinates of this point? Again, x, y. The x values are the same because that's vertical, but the y values are different. So we'll call that one, we'll call the top one y sub 1, we'll call the bottom one y sub 2. So our radius goes from this line to here. Now we're going to have to use our 3 bracket method, right? We do 1 bracket from our axis of rotation to our point. We do another bracket from our point to our axis, one of the x or y axis. So how far is it from here to here? Well, that's x, isn't it? Because that's where that's how the Cartesian plane works. The distance from the y-axis out, that's going to be x. And then our third bracket, remember, is the entire distance from our axis of rotation to our nearest axis. And we know that that distance is 1. So doing some scratch work here, we have x plus r, right? Those 2 brackets add up to that bracket, that's 1. We're trying to find the radius in terms of x. So our radius is going to be 1 minus x. That's in terms of x, so we're good to go. What about our height? Well, our height, right now I'll move this over a little bit just in case we need some more room. Our height is y sub 1 minus y sub 2. Now, who is y sub 1? We said y sub 1 is a top function, so that's going to be 2 minus x squared minus y sub 2, which is also x squared. So we get 2 minus 2x squared. And now we're ready to plug it into our formula. Our volume is going to equal 2 pi. We'll put our constant out in front. Now we're integrating, right? This is our shape. This point of intersection is -1. This point of intersection is 1. So we're integrating from -1 to 1. Now, we can't use symmetry here and multiply by 2 because we're not symmetric with respect to the y-axis. We're symmetric with respect to the line x equals 1. So we have to keep our bounds from -1 to 1. Our 2 pi is in front. Our radius is 1 minus x. Our height is 2 minus 2x dx. So we could factor a 2 out, right? We could factor a 2 out, make that 4 pi, integral -1 to 1, 1 minus x. This is also, as it turns out to be, 1 minus x when I factor out that. And now I'm going to just FOIL. That's going to be 1 minus 2x plus x squared, just FOILing. We're going to get 4 pi. We're going to integrate The integral of 1 is x. The integral of this is minus 2x squared. Remember to divide by 2. The integral here is going to be plus x cubed over 3. And we're going to evaluate between -1 and +1. And again, I will leave the arithmetic to you. All right. So that's 3 examples on how to do the homework in 6.3. I'll see everybody in class.